So now we are going to measure the concentration of reactive clays in this sample of mud we have right here. We are going to be using a method which is called the methylene blue method, which is a method in which the methylene blue is going to be absorbed into the active clays of the system. So the more methylene blue we have to use to get the final point, the higher the concentration of reactive clays, such as, for example, bentonite and in general smectites, are going to be present in that fluid. The first thing we are going to do is start with 10 milliliters of distilled, or in this case, deionized water, and we place it into this Erlenmeyer flask. Then 1 milliliter of sample. I can use a pipette for this. Here we are going to have exactly 1 cc. Then we are going to use peroxide, hydrogen peroxide, 3%, and we are going to put 15 milliliters. This is going to make sure that we oxidize or burn all the organic compounds that we might have in this fluid. In chemistry, we call it digestion. This is going to oxidize all the organic matters that we might have there, including, for example, lignites and lignosulfonates, to make sure that the methylene blue is going to absorb only on the reactive clays. One more thing is to help in the digestion and to raise the pH. We are going to put half a milliliter of 5 normal sulfuric acid. That's kind of a strong concentration, and half of a cc will be enough for our purpose. Again, raise the pH and help in the digestion process. There is half a cc. Now we are ready to heat to a very slow boiling. The reason for that is, yes, we want to have a digestion here, but we don't want the water to evaporate, because we are going to have to make a titration based on this solution and suspension. So we need all the water we have right here. As soon as I see that the boiling starts, I'm going to reduce the temperature using this regulator. Since I can see that there is a little precipitate, just in case, to prevent the formation of a cake at the bottom of this Erlenmeyer flask, I'm going to scrub it a bit using either a pipette or maybe a screwdriver. Let me see if this works. Oh, it's doing okay. There's a little film at this bottom, which is exactly what I'm removing right now. It doesn't happen all the time, but it's something that could occur. And if you notice that deposit at the bottom of the Erlenmeyer flask, it's better to scrub it gently. Since this is starting to boil, and this is at the maximum temperature, I'm going to go ahead and reduce the temperature, because I want a slow boiling to make sure that water doesn't evaporate. And I'm going to count 10 minutes. Once every few seconds, I'm going to stir it, because this is really not a homogeneous liquid. It has phases, and I want to make sure that everything gets exposed to the digesting additives we put there, especially hydrogen peroxide and 5 normal sulfuric acid. This is already simmering, as you can see. That's exactly what we wanted. Make sure that we keep the thermostat in such a position that grants a constant slow boiling. So we might have to adjust that thermostat a few times during the 10 minutes of digestion. This seems to be going very well. This is the end of the 10 minutes, and I'm going to proceed to turn off the hot plate and also remove the Erlenmeyer, put it here. And now I have to add 50 cc's of distilled or deionized water and also let it cool. Now this is going to cool it pretty much. But it's not going to be cool enough, so we'll have to wait. So this is already considerably colder. This is already considerably colder. As a matter of fact, I can touch it, but we still have some way to go for this thing to cool down all the way to room temperature. Now, this is cold enough. I'm going to get one regular filter paper, and I'm going to treat it like a pizza. I'm going to go ahead and slice it with lines, and that's going to give me 8 sectors. So now I can put some samples here and see what color it turns out. First one is going to be half of a cc of 1, 1.5, 2, 2.5, 3, 3.5, 4. So the first thing I'm going to do is to add half a cc of methylene blue. For that I can use a syringe. So what I can do is grab this from here, and since I'm going to be titrating, I'm going to go ahead and get 3 cc's and then use half a cc at a time. Here I am at 3, exactly. So I'm going to go ahead and put my first half of a cc. Stir it for 20 seconds. And you can see that this is of a very intense blue. It's going to continue being intense as I continue increasing the concentration of methylene blue. And at the end of the 20 seconds, I'm going to grab this rod, glass, and just deposit 1 drop in the corresponding to 0.5. Next step, another half of a cc. Again, stirring for about 20 seconds. End of 20 seconds. And now I got a total of 1 cc of methylene blue in this mixture. So I put it in the number 1. And so far, all these drops gave me a typical bluish color that doesn't tell too much. Eventually, a halo will develop, which is going to be of a greenish blue tone and very easy to recognize. We can see a trace of a halo, so it's starting to show that the reactive clays present in this suspension are already absorbing all the methylene blue they can. So now I'm going to go to the 4 cc mark with another drop. Not very clear, so we are going to continue. The halo is not there yet. So half a cc more. Looks like we are getting close. And now we are going to go to the 4.5. Corresponds to the amount of methylene blue used so far. Looks like we are getting closer. So half of a cc more. mixing, agitating, and ready for the drop corresponding to 5 cc's. So I'm going to put it next to this one. I want to wait because I believe that now we have a clear halo. Since this is convincingly a green halo around the blue spot, I'm going to continue agitating for 2 minutes without adding more methylene blue, because I want to confirm that the agitation was enough for the clay to absorb all the methylene blue and have an excess so as to be able to give us another green halo. So the drop is going to be again with 5 cc's total methylene blue, and I'm going to put it not far from the other one, for example in an empty space here. And I'm clearly getting a confirmation that there is a green halo. That means that we have already reached a saturation point for that reactive clay in which it cannot take any more methylene blue. So the final point is then 5 cc's of methylene blue corresponds to 5 milliequivalents of methylene blue per milliliter of solution or suspension, and that multiplied times 5 is going to give us the concentration of bentonite in pounds per barrel equivalent. So we are in a position to say that the total reactive clays we have in this mud sample are equivalent to having a concentration of 25 pounds per barrel of sodium montmorillonite, bentonite.